All right, everyone, we're back with another Advent of Code 2021 problem that we're working on in Uiua language, the really fun, really interesting array programming language. And on day 9, we have the smoke basin. So I'll read the problem and then we'll go ahead and switch over to Uiua and start solving it. So, day 9, smoke basin. These caves seem to be lava tubes. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the nearby caves for you, your puzzle input. Smoke flows to the lowest point of the area it's in. For example, consider the following height map. We have a two-dimensional array of digits from 0 to 9. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest a location can be. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. Most locations have 4 adjacent locations: up, down, left, and right. Locations on the edge or corner of the map have 3 or 2 adjacent locations, respectively. Diagonal locations do not count as adjacent. In the above example, there are 4 low points, all highlighted. 2 are in the first row, a 1 and a 0. 1 is in the third row, a 5. And 1 is in the bottom row, also a 5. All other locations on the height map have some lower adjacent location, and so are non-low points. The risk level of a low point is 1 plus its height. In the above example, the risk levels of the low points are 2, 1, 6, 6. The sum of the risk levels of all low points in the height map is therefore 15. Find all of the low points in your height map. What is the sum of the risk levels of all low points in your height map? So we have the two-dimensional array, and it looks like we're going to be comparing with the values directly left, right, up, and down from each point in order to see where the low points are. After we find the low points, we'll select them from this starting array and then add 1 to each one and then sum those up. So it's pretty straightforward as far as these problems go. So let's jump in and get started. So I have the environment set up. This is my example input, which we'll work with. So in Uiua, I'm going to start by just bringing in the example, importing it as a string. This is file read as string. And I want to split that on new lines. Get my fingers aligned on the keyboard here. I'm going to say by different than part parse. So that gets us long numbers, but I actually want to parse each. So we get our input array from individual digits. And it's 5 lines. Just seeing that the proportions of our rectangle look slightly different. So that's good. And First thing I want to do is just duplicate this array, because I know that at the end I'm going to be picking the values that are the low points. So let's just work on the duplicate array. And I'm going to do a by shape. I want to add a row of infinities to the bottom to see, so that I could perceive the top or the bottom of the array as a low point when I rotate it. So I'm going to say, oh, what if I say just join infinity? I think that will work for what I'm trying to do. So the idea is that when I wrap around, if I rotate this 9 sees itself as being next to an infinity below. And this 9 sees itself as being next to an infinity above. And maybe that'll become more clear as I'm going along. So I want to say, well, actually I'm curious about if I do under join infinity. So inside of here, I get what I want. But I think that just is unnecessarily complicating right now. Let's not do that. Let's just work on this one. So what I want to do is by rotate 1, so this is rotated this row up. I want to say, are we less than, or is this greater than? I think I actually want less than. Are we less than the value below? And I'm going to start to put this into a fork. So that I can continue working on this array. Actually, it'll be easier if I do on right here. And the array that I want to work on stays below. And we will say by rotate -1, okay, actually I preserved the wrong array here. now I'm confusing myself. So there's another operator that I want, which is might be under or below one of these. So I really want on, but let me see if I can reason for on. Maybe with. Yeah, with is what I want. And you see I haven't colored with appropriately yet. That's something I'll do. So now I can do by rotate -1 with less than. And we will take the min of these to do a logical AND operation. So this is comparing up and down direction. And I want to pull this out into a function. And I'm going to say under actually want to do on F under trans F. So after I do F, I need to make sure that I drop the first row. Now we'll do the min. Okay, looks like we found our 4 minimum low points rather. That's good. Now we'll do select, I think. No. It's not unaware, do both the shape. Keep, add 1, sum them up. That gets us 15, which is our correct example answer. So let's go ahead and try this on our special input, and I got 600. That's correct. Let's check out part 2. So it's for part 2, it says, next you need to find the largest basins so you know what areas are most important to avoid. A basin is all locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being in any basin, and all other locations will be part of exactly one basin. The size of a basin is the number of locations within the basin, including the low point. The example above has 4 basins. The top left basin is size 3. The top right basin is size 9. So we're seeing values flowing, sometimes in lines that move at right angles to that low point. The middle basin is size 14. So there's this notion of flow in the numbers. Find the 3 largest basins and multiply their sizes together. In the above example, this is 9 times 14 times 9 equals 1,134. What do you get if you multiply together the sizes of the 3 largest basins? Okay, so this is considerably more tricky than part 1. So we'll see what we can come up with as we're thinking about this problem. So I'm going to say part 1 and this is the point that I'd like to start from for part 2. That's got to go below the function definition. So what we have are our low points in a 2D array and pointing to this input array. So how do I best capture the 3 largest basins? So this is going to require some thought, so I'm going to stop for now and pick up part 2 after I've thought about it for some time. So thanks for watching, and I'll catch you next time.